All right, let's jump right in. You know those amazing AIs that can create an image just from a few words? Well, at their core, they have to solve this one huge puzzle. How do you teach a computer that a picture of something and the word for it are, well, the same thing? Sounds easy, right? But for an AI, it's one of the trickiest problems out there. So really think about it. How does an AI figure out that this picture and this word are connected? I mean, it doesn't have eyes or a brain like ours. It's starting from zero, just looking at tons and tons of data. And it turns out the way we teach it is everything. The best way to think about this is like a game, a matching game. The technical name is contrastive learning, but basically we just show the AI a ton of pairs. Some are a match, like a picture of a cat and the word cat, and a whole lot more that don't match. The AI's job? Figure out the rules. So the ultimate goal is for the AI to create this kind of shared map in its digital brain. Researchers have a fancy name for it, but just imagine a giant map where things that mean the same thing are clustered close together. So the picture of a snowflake and the word snowflake are neighbors, and they're both miles and miles away from the word, say, volcano. Okay, so for years, the go-to method for teaching this was, well, let's just say it was pretty tough on the AI. It's kind of like making it solve a crime over and over again. We're going to call this the lineup method. So the actual term is softmax loss. And here's how it works. The AI gets shown one single image, but then it gets this massive group of text descriptions. Its job is to look at all of them all at once and pick the one correct match. Talk about pressure. Seriously, just think about that for a second. It's exactly like a police lineup. You're the witness, and you have to pick one suspect out of a lineup, but the lineup has thousands of people in it. That's what we've been making these AIs do. And the crazy part is, the AI can't just look at one option at a time. Nope, it has to keep that single image in its head and compare it to every single text description in that huge batch, all at the same time. This global view makes the whole decision incredibly complex and, you guessed it, super heavy on computing power. And this is where we hit a massive bottleneck. It's crazy expensive because holding all that information in memory is a nightmare. It's super inefficient because to get good results, you need those lineups, those batches of data to be just gigantic. It all adds up to a process that's just plain hard to scale up. But what if that's just the wrong way to ask the question? What if instead of this huge, complicated lineup, we could just ask the AI a really, really simple question? Well, that's exactly what a new paper from Google DeepMind proposes. They introduce a new method called SigLIP. Yeah, it's a bit of a mouthful, but the idea behind it is a total game changer. It simplifies the whole task. The big idea with SigLIP is to just reframe the entire problem. Forget the lineup. Just get rid of it. Instead, the AI looks at just one image and one piece of text at a time. And its job isn't to pick the best one anymore. It's just to answer a simple question, are these two a match? That's it, a simple yes or no. So let's go back to our analogies. If the old way was that stressful police lineup, the new way is way more chill. It's like a matchmaking app, right? You're not trying to pick the perfect person out of a giant crowd. You're just looking at one profile at a time and deciding, is this a match? Yes or no? Swipe right or swipe left? And that comparison really just nails it, doesn't it? The old lineup method asks this really complex question. Out of all these options, which one is the right one? But this new yes/no method just asks, is this specific pair a match? It's a much simpler question, and that simplicity echoes through everything. The math, the code, the amount of memory you need, it changes the whole game. Okay, so the idea sounds awesome, right? Simpler is almost always better. But does it actually work in practice? The answer is yes, and the results weren't just good, they were honestly pretty surprising, even to the researchers. I mean, just look at the data. When they put the two methods head-to-head, this new sigmoid approach just cleaned up, especially when using smaller batches of data. And that's a huge deal. It means you don't need a massive, expensive supercomputer to get really, really good results. But wait, that's not even the most surprising part. See, for a long time, there's been this golden rule in AI training. Bigger is always better. The more data you can stuff into one of those lineups, the smarter your AI gets. Well, this paper basically took that idea and flipped it on its head. And the whole thing came down to this one number, 32,000. Turns out, once you get to a batch size of about 32,000, the performance for both methods just flattened out. It hit a wall. Making the batch any bigger gave you almost nothing in return. This proved that bigger's always better just isn't true. There's a good enough point, and it's way, way smaller than most people in the field assume.
So what's the big takeaway here? Why does a change in the math matter to the rest of us? Well, because it's not just a small technical tweak. It's about who gets to build the future of AI. This SigLIP advantage is huge. First, it's way more accessible. The paper shows you can get top-tier results with just a few computer chips, not a whole data center. Second, it's more efficient, which saves a ton of money and electricity. And, maybe most importantly, it's more robust. It actually works better with the kind of messy, imperfect data that you find all over the real-world internet.
And the researchers themselves put it perfectly in the paper. They said they hope this will, and I'm quoting here, facilitate language image pre-training research with limited resources. That's what this is all about. It's about opening the doors for more people, more universities, and smaller companies to get in on this research. So, in the end, just changing the question from a complicated pick one from many to a simple is this a match didn't just make things faster. It actually challenged one of the core beliefs of the entire field. And it leaves you wondering, right? If bigger isn't always better, what other big assumptions are we making about AI that might be totally wrong?